looking at speed in the previous video, a closely allied idea is that of angular velocity. Let me just say this comes up a lot in various physics calculations. So, suppose that you have a particle moving around a circle of radius big R. In physics, you often write this as C of t is r cosine omega t, r sine of omega t. So it's cosine of omega t, sine of omega t, where what is this omega? This omega is the angular velocity. And in words, it's the rate of change of the angle theta with respect to time. So let's say that here is your particle moving around here. It's radius r. So this angle here is theta. How fast is theta changing as you move around the circle? It is, it's almost a little bit more common to see this measure of velocity than the speed in the previous the previous video. So let's just, but it turns out those two are closely related. Let's see that in this next slide. Find the speed of the circular path of radius r and angular velocity omega. So I'm just using this right here. C of t is r cosine omega t. It's comma r sine omega t. So when we take derivatives of these two, we're going to pop out factors of omega out in front from the chain rule. So x prime of t is minus omega r sine of omega t, and y prime of t is omega r cosine of omega t. So when we calculate speed, we're just going to square those, add them together, and take the square root. So what do we end up with? Square root of minus omega r sine omega t squared plus omega r cosine of omega t squared. And let us see here. We end up with omega squared, r squared, sine squared of omega t, plus omega squared, r squared, cosine squared of omega t. And can you see what's going to happen here? We can factor out omega squared and r squared times sine squared of omega t plus cosine squared of omega t. And so what's going on? This is going to be sine squared plus cosine squared, of course, 1. The square root of omega squared plus r squared is going to be the absolute value of omega times r. So r, we're assuming, is strictly positive. Omega, the angular velocity, could be positive, could be negative, so we'll slap absolute value bars on that. So here we see that the speed, this is the speed here. So how do we find the overall speed if we know the angular velocity? We just take absolute values of it in case it's negative, and then multiply by the radius. So the angular velocity and the speed are proportional to each other. That's the moral of the story here.